What is Monte Carlo simulation? Open the Excel file named normal.xls. This file contains neither macros nor Monte Carlo simulation on it. We will demonstrate how Monte Carlo simulation is performed manually in Excel. Let us recall that Monte Carlo simulation essentially combines two concepts. One, the generation of random numbers, and two, probability distributions. So, generating the random numbers. We begin by generating a random number in Excel. To do this, we use the function rand. This is a volatile function, meaning it does not require arguments between its parentheses. Every time we press F9, recalculate, a continuous random number between 0 and 1 is generated. This allows us to create random numbers in Excel. Next, let us create a probability distribution. The simplest and most universal probability distribution is the normal, the Gaussian distribution. This distribution, remember, requires two parameters, a mean, in this case of 300, and a standard deviation, in this case 100. The standard deviation measures variability relative to the mean. With these two numbers, we define or limit the range of visualization. A normal distribution theoretically spans from negative infinity to positive infinity. To limit this, we set the range between mean minus 3 times the standard deviation, that is the minimum, 0 in this case, and the mean plus 3 times the standard deviation. That's the maximum of 600. So from 0 to 600 is our limiting view range. This allows us to generate random numbers between 0 and 600 for a normal distribution with a mean of 300 and a standard deviation of 100. Now we calculate probabilities. For example, let us consider the value of 400. For this value, the normal distribution function in Excel, the function norm.dist, requires the following parameters: an x, which is the value, in this case 400, a mean, which is 300, a standard deviation, which is 100, and a true for the cumulative parameter. When calculated, this indicates that there's an 84% probability of generating a value up to 400 in a normal distribution with a mean of 300 and a standard deviation of 100. If we change the value to 300, the distribution symmetry means that 50% of the data will be below 300 and 50% will be above 300. Thus, 300 corresponds to the median or 50th percentile. Now, let us generate a random number similar to the previous example using another Excel function, the rand between function. This function generates random integers between a minimum, 0, and a maximum, 600. Each time we press F9, it generates a random number within that range, which can be represented on a graph as a random point. So on a cumulative visualization, each time we press F9, we generate a different random number, calculate this cumulative probability with norm.dist, and observe it on a graph. For instance, a random number of 65 has a cumulative probability of 1%. A random number of 340 accumulates a 66% probability. This analysis can be extended by generating more random numbers. For example, using 5 points, each would have its corresponding probability. By increasing the number of points, 10, 20, 100, or even 500 data points, samples, the cumulative probability curves becomes denser, offering a more detailed representation. Finally, by generating 500 random data points, the complete curve is constructed cumulatively. Each time we press F9, Excel generates 500 random numbers distributed according to the S-curve of such a normal distribution. Now we integrate the concepts. This is essentially Monte Carlo simulation in the making, combining 1. Random numbers and 2. Probability distributions. This manual procedure provides a basic example of how Monte Carlo simulation works. Tools such as EasyRisk Quantum, integrated into Excel as a ribbon, automate this process. EasyRisk Quantum enables the generation of more complex simulations, of course, managing multiple variables with probability distributions and random numbers efficiently. So this is Monte Carlo simulation, manually implemented in Excel.